Hello students. After the discussion on the Thomson atomic model, now let us discuss another important model of atom that is called Rutherford nuclear model of atom, which was proposed on the basis of his experiment, that is Rutherford gold foil experiment. Rutherford is known as the father of nuclear physics. He is famous for his work on the radioactivity and the discovery of the nucleus of an atom with its experiment, that is gold foil experiment. For his work, he got Nobel Prize in Chemistry in 1908. So let us discuss the gold foil experiment proposed by E. Rutherford. Rutherford was interested in knowing how the electrons are arranged within an atom. So, Rutherford conducted an experiment. In this experiment, the fast moving alpha particles were made to fall on a thin gold foil. Now, the question arises here, why thin gold foil is chosen here? Because he selected a gold foil because he wanted as thin as layer as possible. This gold foil was about 1000 atoms thick. So he chosen gold foil for his experiment. And the alpha particles which is made to fall on this thin gold foil, so definitely the question arises, why the alpha particles were chosen? As alpha particles are doubly charged helium ions since they have a mass of 4 atomic unit. The fast moving alpha particles have considerable amount of energy. It was expected that alpha particles would deflect by the subatomic particles in the gold atoms, since the alpha particles were much heavier than the protons. So he did not expect to see a large deflection. So because the alpha particles which were much heavier than the proton, so he did not expect to see a large deflection. So he chosen alpha particle for his experiment. So let us discuss how he conducted his experiment. In his experiment, the fast moving alpha particles were made to fall on the thin gold foil. The alpha particles were emitted from radioactive substance which is taken in this container, which is called as source of alpha particles. So alpha particles is emitted from this source, that is a radioactive substance. So these alpha particle which was made to fall on the thin gold foil. So let us see what are the observations which he made here. Since this gold foil was taken in a circular fluorescent screen in order to detect the deflection, that means how these beam of particles of alpha particles that is get deflected. During his experiment, he observed that most of the alpha particles were made to pass through the gold foil were get undeflected. That means they have passed through the gold foil without any deflection. So that is the observation he made. And also he found that some of the alpha particles were deflected by small angles like this. So some of the alpha particles were found to be deflected by small angles. And he also observed that very few particles were appeared to be rebounded like this. Once again, look at this observation in the gold foil in this way. So gold foil, that is the number of gold atom which is shown here. So what is in this diagram, it is clear that most of the particles get undeflected. That is, when it is passed through the gold foil, it get undeflected like this. So this shows that there is large amount of empty spaces are there in an atom. And even he found that some of the particles get deflected by a small angle and very few which was rebounded, which you can see here, very few are rebounded. On the basis of the observation he made during his experiment, he concluded that most of the space inside the atom is empty because most of the alpha particle pass through the gold foil without any deflection. Since most of the alpha particles which he found is passed through the gold foil without any deflection, it shows that in an atom there is an empty space is there. That means most of the space inside the atom is empty. And he also observed that very few particles were deflected by their path. It indicates that the positive charge of an atom occupies very little space. So within an atom, a large space is actually empty space is available in an atom, and the positive charge is occupying a very little space in an atom. But he also observed that very few particles get turned back. So on the basis of this, he concluded that all the positive charge and the mass of the gold atom were concentrated in a very small volume within the atom. So this region where all the positive charges were concentrated in a very small region within atom, he called this region as nucleus. On the basis of his experiment, Rutherford put forward the nuclear model of atom. Let us see what are the important features of his model. There is a positively charged center in an atom which is called as nucleus. Nearly all the mass of the atom resides in the nucleus. So the nucleus is positively charged because of the presence of proton in it. So the positive charge is concentrated at the center, which is termed as nucleus. The electrons revolve around the nucleus in a circular path. That means the positive charge which is present at the center, which is termed as nucleus, and the electrons which is negatively charged, it revolves around the nucleus in a circular path. The size of the nucleus is very small as compared to the size of atom. So these are the three important features of Rutherford nuclear model of atom. That is, the first feature, that is a positively charged nucleus at the center and the electrons which is revolving around the nucleus in a circular path, and the size of the nucleus was extremely small as compared to the size of atom. Here, the electrons are revolving around the nucleus in a circular path, which is called as energy levels. That was described in another model. So, the model of atom was considered to be like a solar system. As in the solar system, planets are revolving around the sun in a definite path. Similarly, in atom also, the electrons are revolving around the nucleus in a definite path. So, this is all we have discussed about the Rutherford nuclear model of atom. But there are some limitations in his model that we'll be going to discuss in the next video. So have a nice day.